All right, good morning, ladies and gents. So today we are continuing on with our serology unit, and we are looking at blood spatter. And yes, it is blood spatter, not splat. Like if you think you drop something that's liquid, it splats. Well, it's spatter, not splatter. So when we look at blood spatter, we are looking at how does blood, which is a liquid, hit target surfaces. And in terms of target surfaces, I mean like a wall or curtains or a window or a desk. And how does that blood act as it strikes those surfaces? Okay, so because it is a fluid, it does follow the laws of physics. It is going to be influenced by the force due to gravity. So when we look at blood droplets, they are going to stay in a spherical shape until it collides with this other surface. So it's similar to when you see water dropping into other water and it has that perfect spherical shape as it's dripping down. The exact same thing is true of blood, okay? So when we look at blood as they're dropping, the shape of those actual blood droplets are going to change based upon whether it is striking the surface with a 90-degree angle or if it is having an acute angle where it's actually less than 90. Okay. Some of the things that we can learn from this or understand why the shapes might change is because of how much blood is actually released. Is it a small drop of blood or is it a larger drop of blood? What angle does it actually impact? How fast is that blood moving? Okay, so you guys remember the law of inertia from 9th grade. If your body is in motion, and let's say for some reason it gets hit by a car, that blood is going to continue with a certain velocity, even if maybe your body changes its motion as well. Okay, so the velocity at which that blood droplets leaves its origin, so that would be leaving the body, how high the blood is actually dropped from, so whether you are standing 1 foot above the ground or whether you are up at 6 feet. Okay, the type of the target surface. So think about it. If I am looking at the wall at school and there's cinder blocks and it's painted, something that is liquid is going to run down that pretty quickly. But if that blood hits the target surface and the target surface is now curtains, curtains have a little bit different properties. They will absorb some of that blood and it won't run down as quickly. Okay, so when we look at the type of the surface, we got to be aware of that. Okay, all right, so things that we would want to answer if we are the one that is trying to look at blood spatter following an actual crime. If you guys have not watched on Netflix The Staircase is such a good example of blood spatter interpretation when they're trying to decide, okay, did he actually yield a weapon and hit his wife while she was in the staircase? Is there blood being flung upwards as he's pulling back the bar as he hits her? So that's a great one. I know you guys have plenty of time right now on your hands. So if you are interested in watching a good sort of case, I would watch that one. That's a good one. Okay. So when we're looking at that blood spatter and we're trying to retrace what happened in the final few moments of that person, we want to look and see, well, where was the person moving? Okay. How many times was that person struck? How many times were they shot? Because that's going to change how much blood is actually released from the body. Okay, just think about like a shotgun. A shotgun that has a bunch of different pellets is going to create a very different image on that target surface than if somebody was shooting like a 9mm gun, which is just one bullet. Okay, same deal whether you're being hit with a bat versus being hit with, I don't know, maybe something softer. Okay, the pattern is going to all be different. Okay, the position of the victim, and then whether or not the victim moved before or after the actual violent crime. Okay. Some of the different terminologies that you guys need to know is your angle of impact, which would be your angle of which the blood strikes your target surface. If there is a blood-stain transfer, when bloody objects come into contact with surfaces and leave those bloodied images on the surface. If there's any back spatter, that's blood that is directed back towards the source of energy. And if there's any cast off. So think about taking a golf club, hitting something, and then pulling that golf club back, and then going to hit it again. When you pull back with the golf club, so that you're in your wind up to go hit again, every time that you pull back, that creates what is called cast off. So the blood actually gets thrown upwards and away from the victim, and that is something that we can identify and say, okay, well, this is how many times the person was struck, and we can see this also in the blood transfer, not just necessarily in the autopsy report. So we would have even more evidence with that. All right, some of the other different terms that you guys need to know is contact stains. Anytime that you are bloodied and you touch something else, it's going to cause a transferring, okay? So a transfer is when we see a recognizable image. So maybe that is your hand, or maybe it is a foot, whatever it may possibly be. So a swipe is when we have wet blood getting transferred to a surface that did not originally have it. So say I'm walking out of the room and I have blood on my hand and I touch the wall to steady myself, I can transfer blood that way. Okay. A wipe is when I actually see objects move through blood stains. This is one of the most common ones, which is kind of weird at the same time. Think of a Roomba. A Roomba moves around and around and around your house at different points. So one of the things that they have actually seen is sometimes Roombas will move through a crime scene when the body has not yet been discovered, and you'll see that that Roomba actually tracks the blood elsewhere into the house. So that would be a wipe, and it actually alters the original stain, which isn't really the best thing. All right, we can determine what direction the blood was actually moving, because when that blood actually hits the surface, then gravity is going to start pulling it down, and the tail always points down. So when you look at a blood stain, it'll look kind of like this, where you have an elongation and then it gets a tail all the way down. And so the tails always point in the direction of the blood flow. If you guys watch the Making a Murderer series, in the second season, they actually talk about why is the blood transfers, if he actually threw her into the back of his car, should look something like that, where we have the blood. Let me see if I can make this a little bit better. A little bit more elongated, so you have more of a blood circular, and then you have the tail, because then that would point in the direction that the body was actually moving. So what they should have saw with the actual woman being thrown in the back of the car is shapes like this, where the tail actually points to the left, to the inside of the car. What they actually saw was this, which means blood was actually dropped down. So this actually adds to the conspiracy that it was planted there by the police, because they used pipettes and they dropped the blood, her blood, onto his car. So if you do that, you would eventually make an image similar to this, where the blood's actually pointing down, when I should have saw something like that. Okay, which is kind of crazy. So if you haven't watched that one yet too, you should totally watch it. All right, so in terms of speed, if we look at things that have a high velocity, this would be something that generates 25 feet per second or 100 feet. Oh, sorry, backtrack that. I reread that wrong. It's anything from 25 feet per second to 100 feet per second. I know our in science class should be meters per second, but something like that would give a nice fine misting. A medium velocity would be anywhere from like 5 to 25 feet per second, and then low velocity would be 5 feet per second or less. And that's how fast the blood would actually be moving. When we look at those, some of those examples would be like using a gun versus using a baseball bat versus using a car. Okay, each of those, when striking a victim, are going to generate different blood patterns. Okay. All right, again, here, if you take a look, here is that directionality. So do you see how it is more of an oblong, and then the tail points down? That allows for us to see it. As you change the angle, if you're hitting it with a perfect 90 degrees, so say you have a piece of paper and the blood drops down, a nice circular perfect shape is what I would see here. But as we change that angle, and let's say now the paper looks like this, and I drop the blood here, do you see how the angle between the surface and the actual paper is a little bit different? Okay, so at about 30 degrees, we start to see this tail being produced there. Okay, the more acute the angle, the easier it is to determine our direction of travel. All right, so looking at those patterns again, depending upon the surface type, we see different patterns. Now, I will say all these patterns, everything that we are talking about, would be recreated in a lab, because we would want to make sure that when the prosecutor is certain of this is what I expect happened in the final moments of the person, they want to be able to present that to the jury. And so the forensic scientists would actually create a very similar situation in the lab, where they would have dummies and they would put hair on the dummies and they would apply blood and then maybe strike it so many times with a similar weapon to see if the cast-off pattern and the blood patterns that we see on the surfaces match this, so that we can definitively say, hey, this is what we believe. Now, when we take a look at all this different cast-off and blood stains and spatter that we see on all the different walls, we can actually use a technique that uses string in order to determine exactly where the body of origin was. Where are all of these blood spatters coming in? And this would be in terms of a 3D space. Okay, so that can help us again with modeling and computer-generated simulations, knowing exactly where the person was positioned as they were hit. Okay. All right, so when we take a look at blood evidence, just knowing that it is type A or type B, this is class evidence. But if you can actually isolate some of those white blood cells and collect DNA, that is an excellent piece of tool, because now it is individualized, and you can get a pretty good match there. Sometimes when we look at patterns, the patterns in the court of law is usually pretty circumstantial, and the reason is because it leaves many avenues for interpretation, if that makes any sense. If you watch the actual evidence from the making a murderer case, you will see that both the prosecutor and defense actually bring experts that they claim are experts in blood stain patterns, and they give two very different tellings as to what happened to Teresa Halbach in her final moments. Okay, so if we use a lot of computer generation, or we are actually able to recreate it in the lab, that gives it a little bit more support, but do understand this is one that is often disputed. So, all right, guys, that's it for today. Thanks.